Alright, welcome back to the video on my channel, map_exe. Today is problem solving video number 14 on my playlist. So this video will contain some unrelated problems. Or I would say problems that are unnecessarily unrelated to each other. So let's see. This is the first question of this video, so this involves sets. So given these sets, S is the universal set that contains all natural numbers from 1 to 30, including 1 and 30. A is the set that contains all multiples of 4, B is the set that contains all multiples of 3, and C contains the set containing all multiples of 12. For part A, we need to find the values of each following right here. So let's just do that. So as you can see, I've rewritten each set in this form so that we can evaluate this pretty easily. So n of A represents the number of elements in set A, which is this thing right here, and then you can just count this and you see that there are 7 elements in set A. The number of elements in set B contains all multiples of 3 from 1 to 30. And if you calculate that, you'll get 10 elements. Now this operation here is translated into A complementary, which means the set of all numbers that are not in A, intersecting B complementary, which means the set of all elements not in B, intersecting C complementary, which means the set in S that does not lie in A. Alright, and if you rewrite the set a bit, I'll just write this. You'll get the set 1, 2, 5, 7, 10, 11, so on until 29. And I'll let you guys just play around with this and just try to discover this by your own, and you'll get the number of sets in this operation will be 15. So actually this operation translates into the set of all elements that does not belong to either A, B, or C. So it is not a multiple of 4, 3, or 12. So that's the set translated in words. Alright, so let's get ready for part B. For part B, we need to show that A intersecting B complementary, and all of that union C will be A. So let's see. So we have A intersecting B, which will be, I'll just rewrite the question right here. Now we can just substitute our simplified sets into this thing. So if A will be 4, 8, all the way up to 28. Intersecting B complementary, which is the set of all elements in S that is not a multiple of 3 as it is in the definition of B there. So that will be 1, 2, we exclude 3 since 3 is a multiple of 3, 4, 5, all the way up to, let's see, that will be 29. And of that union C, which is set 12, 24, as you can see there. Alright, the thing in parentheses will simplify to 4, 8. We'll skip 12 since 12 does not belong in B, but it belongs in A. However, 12 does not belong in both sets, so we can just exclude that. So that will be 16, 20, 24 does not belong in either of these two sets either. It only belongs to A. So we can just skip that and we'll get 28. And now that you guys get through all of this, I would probably like to a Venn diagram to represent this. I'll just let you guys do that. And then we have union 12, 24. And this thing will be 4, 8, 12, which will be also included here. 16, 20, 20, 24 will also be included here, and 28. And notice that this is the set of all multiples of 4 between 1 and 30, which is exactly the definition of set A. So we have proven this claim. Alright, so that's for the first question of this video. Let's jump into the second one. So here's the second question of the video. The first part, we need to factor a to the 4th minus b to the 4th completely. Notice that this is a difference of squares with its terms being a squared and b squared. So that would be a squared plus b squared times a squared minus b squared. And notice we can just factor this part complete again by noticing that that is again a difference of two squares. So that will be a plus b times a minus b. So this is the final answer since we cannot factor it again. So for the second part of part A, find the value of 25 to the 4th minus 15 to the 4th. Well, using our factorization here, we can just suppose A to be 25 and B to be 15. So substituting into this formula, we'll get 25 because that's the value of A plus 15 squared times 25 plus 15 times 25 minus 15. And that will be 25 squared, which is 625. 15 squared will be 225. And the rest of these will be 40 and 10 respectively. I'll just rewrite that 40. There we go, and there we go. So 625 plus 225 will be 850 multiplied by 40 times 10, which is 400. And calculating this, you'll get 3,400. So let's see. We have how many zeros here? Let's see. That will be 85 times 4, which will be 240 plus 3 zeros, which is this thing right here. So this is our answer. For part B of this question, we need to simplify this expression. So I'll just rewrite that for you guys. That will be a squared minus a minus 20 all over a squared minus 25 times a squared minus a minus 2 all over a squared plus 2a minus 8. Now the first thing you might want to consider is to factor each of these trinomials, and you can do that. So notice that the first part of this will factor as a minus 5 times a plus 4. So that's the factoring. While the bottom part is difference of two squares, that will be a minus 5 times a plus 5. And you notice immediately that the a minus 5s will cancel. Multiplied by this thing, a squared minus a minus 2. And if you factor that, you'll get a minus 2 times a plus 1. While the bottom part, let's see, we will have a minus 2 times a plus 4. Now you guys check that for the factorization. So the a minus 2's cancel and the a plus 4's will cancel, leaving us with a final answer of a plus 1 over a plus 5. That is it. So that's it for the second question of this video. Let's jump into the last question of this video. Alright, so this is the final question of this video. So let m and n be positive real numbers such that it satisfies this expression, and this expression will be equal to 0. Find the value of m plus n. Now this problem involves knowing that the range of the square root of x is always greater than or equal to 0 for all real values x. Likewise, the range of x squared will be always greater than or equal to 0. So we need to keep this in mind. However, notice, if one of them will be positive, then this will be greater than 0, and there's no way to change it back to 0 since there is no way for one of these to be negative. So that leaves us with only one case to consider, which is each term of this expression. So let's just rewrite that. 9m squared minus 4n squared minus 32 all squared. They must be both equal to 0. And you can just check that out if one of them is positive. However, yeah, you can just pretty easy. It's pretty easy to see that. So yeah. So 3m plus 2n minus 8 all square rooted will just be 3m plus 2n minus 8 equals 0. I'm going to add 8 on both sides, so it will be this thing right here. Let's call this equation 1. Now from this part, this term here, we can just square both sides, so that will be 9m squared minus 4n squared minus 32 is equal to 0. We can add 32 on both sides, so that will be that. However, notice that this expression is actually a difference of 2 squares, and we can just factor that out nicely. So we have 3m plus 2n, and we have 3m minus 2n. This is equal to 32. Now notice that this expression is equivalent to the first equation, and therefore we can just substitute 8 into this expression here. So that will be just 8 times 3m minus 2n equals 32, and that means 3m minus 2n equals 32 divided by 8 will be 4. So this will be equation 2. Now we can add both equations 1 and 2, to get, well, the first thing will be 3m plus 2n equals 8, and then we have equation 2, which is 3m minus 2n equals 4. So let's add them up. So this, the 2n's will cancel, and we're left with 6m is equal to 12, and that means m must be equal to not 6 but 2. Afterwards, you can just substitute m into one of these equations, and what you get, that n will be equal to 1. So what is the question asking us? The value of m plus n, and therefore m plus n will be equal to 2 plus 1, which is 3. That is the final answer. Alright, so hopefully you guys enjoyed this video. Please subscribe for more videos, and I'll see you guys in the next one. Goodbye.